So, in a case like this, we can take the sine limit of the sine function independently of the cosine function. So limit as sine x goes to 0 and multiply that with the limit of cos x as x goes to 0. Okay, so that limit of sine x going to 0, that's going to be equal to 0 times cos of 0 is 1. So we have 1 times 0, so that's equal to 0. So there's our limit. Now we could also do some algebraic manipulation here because there's an identity involved here. So alternatively, I'll call this 2. Alternatively, we could apply the limit to the identity. This is 2 sine x cos x is sine 2x. And I can say this is 1/2 sine 2x. As x goes to 0, the 1/2 can be applied afterwards. If I let sine 2x go to 0, it ends up being sine of 0, which is 0. 0 times 1/2 gives us the same result of 0. Okay, so these results actually confirm each other. And for one, I just did the limits individually. The other one, I used the identity and applied the limit. So we could do the same thing here. We could use an identity, or we can, again, apply the limits independently of each other. Okay, so limit of as x goes to pi over 4 of sine x. Okay, this is going to be equal to 1 over root 2. The limit as sine x goes to, limit as x goes to 0 of cos x, not 0, but limit as x goes to pi over 4 of cosine of x. Okay, that's going to end up being equal to, 1 over root 2 as well. So when we multiply those together, okay, we end up with the limit equaling 1/2. And again, if we applied the limit to this form, we would get the sine of pi over 2, which is 1 times 1/2. Again, we would get the same limit. You doing it algebraically or doing it independently using some limit properties. So the same thing here, we could probably figure this out, using strong over weak arguments, but we can do this independently. So I take the limit as x goes to infinity of e to the negative x over limit as x goes to infinity of x. Here this is going to be equal to e to the negative infinity power, which is 0, divided by infinity. Well, that's going to be 0. Okay, and we can kind of see that e to the x would actually go in the denominator, so we have 1 divided by a very strong function. That's going to give us 0 as our limit.